Hello class. Today we're going to be looking at 12.5, the angle relationships in circles. We've got several theorems that we're going to do, and then we'll do a few exercises or examples to practice what those theorems mean. So this first theorem here, if a tangent and a secant or chord intersect on a circle at a point of tangency, then the measure of the angle formed is half the measure of its intercepted arc. So let's take a look at what that looks like. So if I have a secant or a chord, let's make it this. We'll have A and B. And then here we'll have a point, B will be our point of tangency. And we have a tangent line off of that from BC. Then, so the tangent is BC. And the secant, BA, intersect at B. So we're going to have a conclusion then based on the measure of the angle. So the measure of angle ABC is going to equal 1/2 of the measure of the arc AB. So let's take a look at what that will look like with some examples. So let's look at example 1, or 1 and 2, looking at this particular example. It says here, find the measure of EFH. So EFH, that's this angle. That measure of angle EFH is going to be 1/2 the measure of the arc FH. Well, that arc is 130 degrees. Not 1/3, 1/2, sorry about that. So the measure of angle EFH is 1/2 of 130, which is 65 degrees. So let's take a look at arc GH, which is going to be GH right here. So did I type that right? Yeah, I'm sorry, GF. I didn't look at that. This arc right here. Well, the arc of, or the measure, let's put a little point here just so I can say that angle, FGX is going to be 1/2 of the measure of FG, that arc. Well, what is this? Well, I know this one, that's supplementary, so 180 minus 122 is going to be 58. So this is 58 degrees. So 58 is 1/2 of measure FG, or GF. If I multiply each side by 2, then I'm going to find that the measure of FG, or GF as I wrote it here, is equal to 116. The next theorem we're going to look at, I've labeled it B on your paper. Let's make sure I can see everything here. All right, is if two secants or chords intersect in the interior, that means inside the circle, then the measure of each angle formed is half the sum of the measures of its intersected arcs. So what does that mean? Let's draw two chords. Let's draw AD, and let's draw BC. And let's say that they intercept at point E. I'm going to label AEB as angle 1. So we have chords that intersect at angle, or at point E, and that measure of angle 1 or if you wanted to name it AEB, that would be fine, is 1/2 of the measure of the arc AB plus the measure of the arc CD. So this arc plus this arc, and you divide it in half. So let's take a look at what that is like when we're doing it on a problem. So we've got this circle, and we've got AC, the secant AC, and the secant DB, and they intersect at E, and I want to know AEB. So this angle right here. Well, it's going to be 1/2 of this one, 139, and this one, 113. So 139 plus 113 is 252. And half of 252 is 126 degrees. All right, let's go to the third one on this page. Oops, I want to continue to show this next, the examples too. So we're going to have 3 cases on this one. If a tangent and a secant, or 2 tangents, or 2 secants intersect in the exterior, so this is outside of the circle, then the measure of the angle formed is half the difference, this time we're subtracting, of the measures of its intercepted arcs. So let's take a look at a few cases here. So if I have a tangent and a secant, and this is, let's put some letters on here, and we'll call that measure of it, that angle 1, then the measure of angle 1 is 1/2 the measure of AD, that's the larger one, minus BD, the arc. These are the arcs. If I have a point on the exterior, and let's call it F, and we have tangents from F to F, and let's call this one angle 2, and the tangent points E and G. And let's give ourselves another point here so we can name that arc. Then the measure of angle 2 is equal to 1/2 of the measure of the arc EHG, EHG, minus the measure of EG. In the last case, if we have a point on the outside, let's call this one L. And from there we have 2 secants. And give ourselves some points here. Let's call that K and M and N and J. So then that one, and let's call this angle 3. The measure of angle 3 then is 1/2 the measure of arc JN minus the measure of arc KM. Let's take a look at some examples then. We're going to find the value of x on these. So this very first one, I want to know that angle right there. It's going to be our x. So we have 87 and 7 as the intercepted arcs. So we're going to say the measure of angle 1 is 1/2 of 82 degrees minus 7 degrees. Now 82 minus 7 is 75. Oops. Oh, I'm sorry, that's not a 2, that's a 7. That's a 7. So that's going to be 80 degrees. I knew something looked a little wrong. And half of 80 is 40 degrees. And let's once again do the same thing over here. We've got x and we've got an intersected arc here and here. So it's going to be the measure of angle, well, we don't know, measure of x. X degrees is going to equal 1/2 of 200 minus 74. So 200 minus 74 is 126. And half of 126 is 63. Let's do a real quick review of those 3 theorems that we learned. When we have angles that are on the circle, half the measure of these angles are going to be half the measure of its intercepted arc. So the intercepted arc is 120, the angle 60. The intercepted arc is 200, the angle is 100. On the inside of the circle, half the sum of the measure of its intercepted arcs. So this measure of angle 1 is going to be 1/2 of 44 plus 86. So that's going to be 65 degrees. Let's not do a second one on that. And when we have the angles occurring on the outside of the circle, it's going to be half the difference instead of the sum. It's going to be the difference. So the measure of angle 1 is going to be 1/2 of 202 minus 78, which is going to give us 62. And on this one, the measure of angle 2 is going to be 1/2 the 125 minus 45, which gives us 40 degrees. Just a couple more examples. So let's come down here to this company logo. As we're looking at this lovely company logo, we've got measure of FH, this arc, all the way past the G here is 108. And LJ, that's this one, is 12. So if they want to know FKH, that's outside the circle, so it's going to be 1/2 of the difference of these angles. So we have 108 minus 12 is 96, so it's 1/2 of 96. And that gives us 48 degrees. And let's look at this last example here. We've got, we want to find the arc YZ, so that's this arc right here. This one takes several steps, so let's do it one step at a time. I'm going to find this angle first by taking 180. I'm subtracting 113 because that's supplementary, and this is going to be then 67. That makes the last angle in this triangle to be 64 degrees. We learned in the last lesson that this angle is going to be half of this arc. So the arc of WY will be twice 64, so it's going to be 128. So now we know the measures of everything except what we're trying to get to. We know that this one is 128. And we know that this one is 68. So if we take those and we subtract that from 360, that will give us the measure of that arc YZ, and that is 164 degrees.